Hi guys, let's take a look at our division algorithm. We're gonna do some long style dividing. So we've got 369 divided by 9. Whichever one you read first goes inside. So I'm gonna set that one up and I'm gonna space it out so I can keep my column straight. So 369 divided by 9. And if you wanted to take a look at it, how it looks in a fraction, remember again, the one that you read first would go inside. Or if I was imagining, like we've talked before, this is a diving board. This is the guy on the diving board. He wants to go into the pool, inside this division box. So now we have it set up properly. That's the first big step. And then we're gonna take this one step at a time and cover up what we do and don't need. So whatever you got laying around, just cover it up. Let's see what we've got. 3. Is 3 big enough to have any 9s in there? So what times 9 is close to 3? That's not big enough. Move it over. 36. Right here, we need to know what number goes here. We've already decided nothing goes there. If you want to put the 0, you can. Don't have to. Now I need to ask myself, what times 9 is close to 36, but not too big? That would be 4. 4 times 9, 36. With a difference of 0, but we're not done yet. Scoot it over one more time. We still have one more number. Bring that down and ask myself, what times 9 is close enough to 9? Close to be 9, but not too big, and that would be 1. 1 times 9 is 9. Always finish it out till you can see what your remainder is. 0 remains on this problem. So let's check that one. We're going to do opposite operation. Remember that, the O's, if I put the O's like that, like glasses. Opposite operation, the opposite of division is multiplying. That's how we're going to check it. So we're going to take our answer. It's always easiest to do multiplying if you put the longest, not necessarily the largest, but the longest number on top. So we think that 41 times 9 will give us 369. So we're going to put 41 here, multiply it 9 times 1, 9 times 4, and that matched up. So I'll put a little check mark there because it checked out. All right, pause the video, use this same strategy on the next 6 problems all the way through number 7. Let's see how you did on number 2. 315, spread it out a little bit. 3, cover up. Is 3 big enough to have any 3s? Yeah. 1 times 3, 3. A difference of nothing, 0, but we're not done. Something has to go above this 1, so bring it down. What times 3 is close to 1, but not too big? Nothing. 0. 0 has a value of nothing. 0 times 3 is 0. Difference of 1 minus nothing. Difference of 1 and 0 is still 1. 1 minus nothing. We're not done yet. Take it over. Bring down the 5. And now we have to ask what times 3 is close to 15. That would be 5. 5 times 3. 15, always finish it out till the remainder, and nothing remains, no more. Let's check it. 105 times 3, 0, plus 1 more, and 315. It balanced out. We did that one correctly. So pause, make sure you try to work out number 3. Get the same as I did. And then taking a look at number 4, on this one it looks like we ended up with a remainder when you worked that one out. And we've got 40, which is what we got up here. 8 times 0, 8 times 4, 320. But that didn't match up. But if you add the remainder in there, you get 321. Okay, you can pause this, work ahead of me, and then come back to it. 5 times 5, we've got 25. Difference of 0. 1 times 5 is 5. Nothing remains. So we're going to run it through a check. 51 times 5, 5 times 1, 5, 5 times 5, 25. So 255 balances out. Covering up here, 2 is not big enough to have any 5s. 24. Oh yeah, how many 5s? What times 5 is close to 24 but not too big? I would say 4. 5 times 5 is 25. That's too big. So let's do 4. Difference of 4. 4 is smaller than 5. That's what you want. This number should be smaller than that one, always. Otherwise, you didn't take enough of these out. Bring that down. 8 times 5, 40. Difference of 1. Uh-oh, no more up here. That must be our remainder. And in 5th and 6th grade, that's kind of where we stopped right there. So let's check and see with just a regular remainder what it would be. 240. Add that remainder. That's what remains. And then 241 balances out. Okay, 5. That's big enough to have a 5 in it. How many? What times 5 is close to 5? 1. 1 times 5 is 5. Difference of 0. Scoot it over. Drop it down. What times 5 is close to 6 but not too big? 1. 1 times 5 is 5. Difference of 1. Still not done. We need a number above this 0. We're going to keep this column straight. Drop that all the way down. What times 5 is close to 10? 2. 2 times 5, 10. Difference of 0. 112 times the 5. 10. 5 times 1 plus 1 more is 6. 5. And it matched up with nothing remaining. Okay, now we're going to use some front-end estimation using our, what we call booger pickers. Okay, front-end estimation. This is why it's called front-end estimation. We're going to take the last number in each one of these and cover. I'm trying to be in the Halloween spirit. This is the first, last, and only time I've ever worn a fake nail. I'm going to take it off though. It's kind of in the way. Hold on. Okay, that feels much better. So what we're going to do is we're going to cover up the last digit in each one because we're going to estimate where to start. Because right here, 81, how many 81s are in 567? I don't know, but I need to get an estimate because I don't want to try 81 times 1, 81 times 2, 81 times 3. So I'm going to estimate. Cover up the last number on each one. So now how many 8s are in 56? That'll give me a good starting point. How many 8s are in 56? Yeah, about 7. So 7 would be a good place to start. Let's see what 81, take it out to the side, do 81 times 7 and see what you get. Oh, it's exactly right on. Okay, because when we did this, 5, that wasn't big enough for 81. 56, that wasn't big enough for 81, so we had to start with the full thing. We got our estimate by covering up the last digit, and it actually worked out perfectly. So 7 times 81 is 567 with a difference of 0. Always check it. Let's make sure it checked. Which one should go where? We've been putting the quotient on there, and this divisor we've been putting down at the bottom. The one that's longer makes it easier. So 7 there, 81 there. 7 times 1 is 7. 7 times 8 is 56. For the parts of the problem, this is called the dividend. It's on the inside. This is the divisor on the outside, and this is the quotient, your answer. Always circle your answer, and we proved that it did check out. And back here on the story problem with the swimming pool, this is the dividend. It goes inside. This is the divisor. I like to think of it like he's the lifeguard wearing a visor, and he comes to the side of the pool to rescue. Okay, let's keep going here. Try this one on your own if you want to. Use the same steps we used up here on this one. Otherwise, I'll check it with you. 4, not big enough for any 72s. Scoot it over. 43, still not big enough for any 72s. 432. Okay, I don't know how many 72s. I have to ask myself right above this 2, not this space, nothing goes there. What goes here? What times 72 is close to 432? I don't know. I'm going to use my booger pickers to estimate. I have to use one hand. You guys can use 2. There we go. So about how many 7s are in 43? Okay, about 6. 7 times 6 is 42. That's a good spot. That's a good place to try. Go out to the side and do 72 times 6. See what we get. And again, it's exact. Right on. So 6 times 72 is 432 with a remainder of 0. Run it through a check. 72 times 6. 42 plus one more, 43. And it checked. Nice job. Try the ones on the back. 585 divided by 73. 5's not big enough, 58's not big enough, and 585, don't know where to start. Booger pickers, about how many 7's in 58? That would be 8 times 7 is 56. So let's try about 6, 7, 8. Try somewhere around there. 49, 50, 51, 511. Okay, so it might be 8. Let's try what 8 is. 73 times 8, 424, so 56 for 758, 584. Oh, that's close. So what times 73 is close to 585 but not too big? 8. 8 times 73 would be 584. The difference of 1. There's no more numbers here to bring down. If we were working with decimals, we would put decimal 0 and keep going, but we're not. If we were doing fractions, we would do clockwise and make it 8 and 1/73, but we're not. We're going to go right over here. And we end up with 73 times 8, 56 for 758, 581, which doesn't match here. Oops, sorry. 8 times 3 is 24. 24. And that's off by just 1. That's our remainder. 585, and then it balances. Nice job. Okay, last one. This one's an actual full-on 7th grade standard division algorithm. Actually 6th grade. I think it's a 6th grade standard. Let's get this 6th grade stuff stuck in our head so we can fly right through 7th and 8th grade stuff. So we have 2,982, the dividend, divided by the divisor 71. I want to know how many 71s will go in there. I don't know. I have no idea. But I'm going to estimate in just a second. Is 2 big enough for 71? No. Is 29 big enough to have any 71s in it? No. What are you going to do now? Yep, scoot the paper over. 298. Is that big enough to have 71 in it? Sure it is. How many? I don't know. Booger pickers? How many 29s are in, 7s are in 29? About 4. 7 times 4 is 28. So try 4 out to the side. Work ahead of me. Don't copy mine. Pause if you need to. 284. So right here, what goes here? What times 71 is close to 298 but not too big? 4. 4 times 71 is close to 298 but not too big, with a difference of 14. This number has to be smaller than that one to know you did it right. So it is. Good job. If not, you would need to make that number higher. 14 is smaller, but we're not done. Scoot it over one more time. Bring it down, and we want to know what times 71 is close to 142. Exactly. Use your booger pickers. Do your front end estimation. About how many 7s are in 14? Yep, you've got it. About 2. 2 times 1 is 2, and 2 times 7 is 14. Difference of 0. 0 remaining. Run it through a check. Make sure we've got it. 42 times 71. Again, the longer one. It doesn't have to be the bigger one. Either way would work on this one. 1 times 2 is 2. 1 times 4 is 4. Here's your ghost 0 because it's almost Halloween. Ooh, scary. It's there, but you don't really see it. Placeholder. 7 times 2, 14. 28 plus 1 more, 29. These are your partial products because you're on your way to your product. Final answer for multiplying. 2 and 0, 4 and 4. And there's 2,982, which balances out. It checks. All right, nice job. Make a note to yourself to help you remember how you're going to do this tomorrow and in the future. Pause. And now that you have that, One last thing. Use the note you just made to yourself. What are you going to do to solve this one? Do you remember how to do decimals? You have to have a whole number out here. We memorize our whole number math facts. We memorize what times 9 is something, what times 3 is something, what times 3 is something, what times 8 is something. We have to have a whole number out here. So the whole number here, if we move it one time this way, the whole number is 5. You know your 5s. We move it once on the outside, we have to move it once on the inside. Those are now going to work out. Pretend this is a regular 5 now. Cover up. Is 1 big enough to have any 5s in it? No. Is 12? Yes. Before we go any further though, once you've moved that decimal, you got it in the spot where it is, take it straight up and now ignore it like you do your teacher and divide as normal. 1 not big enough, 2, yes, that's big enough to have some 5s. What times 5 is close to 12? 2. 2 times 5 is 10. Scoot it over. We want to know what goes above the 0. We'll bring the 0 down. This is 20 now. Ask yourself what times 5 is close to 20. That would be 4, but not too big. 4 times 5 is 20. 0. This number has to be smaller than the 5. 0 is smaller than the 5, so we did good. And there are no more numbers. So 24 is our answer. Take it out to the side. Let's check it. 24 times 0.5. 5 times 4, 20. 10 plus 2 more is 12. And then we have our magic wall of whatever your class came up with. How many ever times you move off the wall to get to the decimal in the factors? 0 here, 1 time here. A total of 1 move is how many times you move in the product off the wall. 1 time. 12.0, 12. 12 is the correct answer. So our final answer then is 24. And now at this point, if you'd like to do the division house, it's completely optional, extra, up to you. Read the instructions carefully. I know it says to write the equation. I know it tells me over here what to do with the remainder. It tells me how to start drawing, and it tells me what I'm going to do next. You're going to end up with something possibly, here's one from last year or the year before last. Cool little house. Here's one from before also, and it's going to end up looking different based on your specific information. And you can get to pick out what color of background paper you want. It'll totally be up to you. But the basics of it, like if I was to fill this out, most of you guys are, what, age 13, and when it talks about birth month, let's say I was born July 3rd. July is the 7th month, 3rd day. That's how that's gonna work. On some of these, you might have to actually do a Google research to figure out the school address number. The number you'd be looking for, let's say if our address was 825 Sycamore Street. The 825 is the number. If it was 422 Apple Street, 422 is the number. We might be 520 10th Avenue. 520 would be the number. This last one over here, you can cross that one off. You won't be using that. So the way this will work, after I've got my outline and done that, to find the number of doors on your house, divide your age by the month you were born. So the age, 13, divided by the month you were born. Remember, the one you read first goes inside. It says to write the equation. So the month, it says divide your age by the month you were born equals D. I'm going to use D as the variable for doors. So set that one up. The one you say first goes inside. 13 divided by 7. 1 times 7 is 7 with a remainder of 6. It does say up here to just discard the remainder. So I'll just take my 1, and that is the number of doors on my house. 1 door for my house. Okay. Have fun with that The last one, if you want to find the number of raindrops that come out of your cloud, the way you'll do that is you will create your own. You can pick whatever you want up here and create your own. And that will be the number of raindrops. Have fun.